Like that? Okay. So, uh, is it working right? Yeah. Okay. So, for the next 35 minutes, we will talk about a side project I built using Go and how to use Go to build some powerful tools. Before to dive into the subject, I will introduce myself. So my name is Sylvain COMBRAQUE. I'm a freelance architect on Go and React.js. I created an HTTP cache system that is called Sylvain, maintainer of the Cadis cache handler module, and an open source contributor on GitHub. So you can find me on GitHub searching Træfik and Træfik Dev on Twitter. And sorry, I'm a French developer, so sorry for my baguette accent. Not totally my fault. Okay, I don't have any company to promote, so here is my cat. That's Shanti, the head of happiness in my house. So thanks to her to make my life better. Okay, let's replace some context. How I came to work with Go. I used a tool called Træfik, so it's a reverse proxy like Nginx, Apache, or Kong. That is written in Go too, and it's easy to use. If you're an end user, you can set up Træfik to take in entry a CIDR, so a host name that will be redirected to your container, any services that are running on your machine. And after many years to use this solution on my servers, there was an issue. There wasn't any caching system or any HTTP caching system. So I could use Varnish, but I don't like the VCL, so I'm not using this solution. And as Træfik is written in Go, I started to code my own HTTP cache system that is called Sylvain. You can find it on GitHub. It's backed by Caddy system also. So let's see how to make our code faster than existing systems. And here how is faster Sylvain versus Varnish. So to answer to the question, how does Go can help us to achieve performances? I can talk about Go without mentioning the Go routines that are logical threads. That's not physical threads. They are emulated in your system, and you just define a function, and you set the keyword Go in front of your function declaration. So here that's an anonymous function that will make an HTTP request to any service. And when you work with any thread, you can transfer some data between your main thread and your second thread using something called channels. And you use it like that. So here I have an asynchronous function that take a response writer and a request as parameters. And I have the condition if the variable RC that is different of that not equal to nil, and I'm trying to read the data from the channel. So if the coalesceable channel don't have any data in this channel, so it will block the process. And if it's not coalesceable, so we go in the else block and return something. And on the 8th line, I put a nil value in the error backend channel, so I can read it later from my main thread. here is another example. You can just say, okay, give me the first value of the channel that is faster than another one. Here we are waiting for the request context to be done. So either the client closed the request, canceled his request, and the second case is the error backend channel that we saw previously. It will go in the case that is faster to answer it, and won't go in the other case that allow you to handle any crashes or something else without having too much if conditions in your code. And what about multiple objects that are sharing the same signature? So we will use some interfaces that can let you apply the inversion of dependencies. So let's say we have two objects in Go. Here's the Badger and the all-week storages that have many methods declared for each object. So you can define an interface that will define the signature of each function that should be defined on your objects. And in Go, it's not like Java or other languages like that. You don't have to say, okay, my object implements the interface storer. But if your object implements all your methods, it will be considered as a storer. So that's like duck typing or what we have in Ruby or Rails framework. And now, when we want to instantiate a new storage, we can just return a mapping. So in key, you have the storer name and the storer implementation as value. And all of your storer will be an interface, so you can't access your storer property, your storer private properties, because they are not exported through a method corresponding to the interface. In Go, you can pass any data using something called context through your application. You don't have to pass it as an argument to your sub functions. And how do it work? It's like the context in React.js. I don't know if you know it, but here I'm defining a context background that is a blank context. I assign a new value in the context, and in my application, all functions that are taking this context, I can read it in the code later. So we can define a set context function that will take the request as parameter and mutate the actual context to add another variables in it or more data. So in my application, I can mark ctx dot value and pass my context key to get either the cache key or like that. Okay, so in Sylvain, you can load your configuration in different way. The first one that has been implemented is the YAML configuration. So you can define a YAML. And in the get configuration function, you can load the file with a helper that I wrote called a read file that take the path to the YAML file. And using the YAML.unmarshal, you can pass your byte data, and the structure your YAML should match as a key value in your YAML. So you can use it in the container way. So you map your configuration.yaml, and your container will load your data and will proxy to another reverse proxy like Apache Nginx. So in this way, it acts like Varnish or the Kong cache plugin. But that's not the recommended way, because when you use Swan as plugin, you don't have to define any configuration or complex configuration. By default, it will handle in the best way for you your needs, and will configure it more efficiently than you can do. So to use it as a plugin or module extension, if you use Træfik, Caddy, or any Go reverse proxy, you don't have many steps to do to support it. For Caddy on the left, you can just create your own Caddy instance with the xcaddy build, double dash with, and your package. And in the Caddy file declaration, you just enable the cache in the global option, and it works. So that your localhost, all your routes in localhost will be cached, and the responses will be stored in the cache. And just run the Caddy run, and your instance is running on your ports, your TLS port and HTTP port, your classic HTTP port. And for Træfik, it's something the same. You just define experimental key in your Træfik.yaml, and you say, okay, I will use the plugin Swan. The module name will be your GitHub, the GitHub project, and the version you want to use of the version of the plugin you want to use, and just run docker compose up Træfik, and it's working. So to achieve this, we have to talk about the middlewares. So you have your request that will pass in any middleware. So the first one will be the headers middleware. The second one will be the CSRF, the router, and your core action. And when your core action will respond something, it will pass to the router. Then in the CSRF middleware and your headers middleware, and return the response to the client. If your CSRF middleware fails, it will stop the middleware propagation. So it will return directly in the headers and send the response to the client. So to implement the middleware interface contract in Go, and more specifically in the Caddy middleware, we have to implement on our plugin a method called server HTTP that takes 3 parameters. The first one will be the response writer. That's your response that you'll send to the client. The request, that's the input from the client. And the next, that is the next middleware to call to follow the chain of middlewares. And it will return an error. So if your server HTTP return an error, it will break the chain middleware and return the response to the client by sending the response to the upper middlewares. And in this function, we add more context to our request. we define a new custom router because we have to keep the data in the plugin before sending it to the client. Because, for example, your application can stream the response, and we have to get all the response to cache it before sending it to the client to be sure we are storing the whole response. After that, we are improving the context with a new value called the getter context CTX key, and we set the date header to override the client date header. After that, we call the next middleware that is exposing the serve HTTP function, and we pass it our custom writer and our current request, the base request. We can't pass our request we upgraded at the second line because there will be some issues with concurrency if we do that. And after that, we return nil because we don't want to break the middleware chain. So in this project, we implemented the coalescing system support. So your proxy will send only once the request to your upstream if the client are asking the same resource. So let's say you have 40 clients that want to get your logo. It will request once the backend and return you one response that will be shared to any of the askers. So how to do that? We will use the package single flight that is in the standard library. That will be a single flight result, and either we time out or we get a response in a channel. So if we time out, we send an HTTP error to the client and store in the result variable the response channel. After that, we are checking that the result error is nil. Otherwise, we return the error to the client. So with that, you will be able to run your upstream on a Raspberry Pi, for example, and have a tons of users that is requesting your resources. So you can define also some API endpoints in Go. So in the configuration, let's say you have something like that, an API base key, the base path, Prometheus, and Sylvain, and the base path for each keys. So in Sylvain, we have some endpoints available. And to code this, we are just getting the base passes from the configuration. By default, we say, okay, your base path, if you don't provide it, will be /swan-API, and we will loop over our endpoints that should be available. And we use the HTTP handle func that will create a handler that will listen on this path and handle the request if possible. So you can choose your storage using the interfaces, write your own storage. Also, for now, there are 5, but in fact, you have more than 7 or 8 storages in Swan. So you have a storage in file system or what you need. Even on NATs, you can store it. But as it's interfaces, you can write your own storage implementation and see if it's better than the actual implementation and propose it to update the code base. So previously there was something called surrogate keys. That is a concept introduced by Akamai, that is a cloud provider and CDN provider. But now there is something called the RFC that is standardize the behavior and the naming. So now it's called cache group, and you can invalidate by group name. So in the first group you have 3 keys, in the second group you have 4 keys, and on the third you have only 2 keys. And if you invalidate the first group, it will also invalidate the key 1 in the third group. So you'll have only 1 key left in the third group. So the CDN tag invalidation, after the workflow you see, so you serve a cache response, etc. Your upstream will be able to invalidate your key and will re-trigger this workflow once the user will try to load the resource that has been invalidated. So there are 3 major providers that are supporting the cache groups. So there is Fastly, Cloudflare, and Akamai that are the most used CDN providers. You also some ESI tags. That is a way to load multiple parts of a website and let your proxy handle the computation for you. So here I'm asking for article.html. So Varnish will store a document that contains some ESI tags, and will ask, okay, give me the user.php resources, and will upgrade your document with the value of user.php, and return the computed document to the user. So what are the ESI tags? You can define it like HTML tags. So you have ESI include a new resource. You have a source, an alt to display when your source isn't available, and an on error. So if you don't specify on error continue, it will stop the computation of your tag. You have some try-catch blocks, and as it's HTML, if your proxy doesn't support parsing, it won't be interpreted. It will be returned to the client as is, and won't be displayed in your page. So in your tags, you can interpolate some variables, and in your when you try to load the image tag, it will interpret from the cookies sent from the user the type and the logo name. So it can give you something like that. So if your user send you an HTTP cookie type Toto, it will try to load the source /toto.gif. And here with your page that for like an e-commerce website, your e-commerce website will be a template with some ESI tags, and only your welcome block and your shopping cart will change when you render it to the user. So you don't have to regenerate the whole page. Your page will with ESI tags will be stored as is, and will just request the blocks in it. And you can set some different ETL on the main navigation, content, or any other blocks. And the template itself can be stored for 1 day, for example. and each tag will be served from the can be served from the cache system itself, because it will store the response, the minimal response for the welcome or shopping cart block, and voila. So that's compatible with many softwares. So you have Caddy and Træfik that are the most users for that. You can use it with WordPress, Roadrunner, Nginx, Apache, etc. So many open source projects are using it. CWA, .rocks, PicoSH, PlatformSH, and even little names like Louis Vuitton or Mercedes are using it. So that was some funny part to dev in this project. But when you talk about HTTP cache, you have something called the RFC. Does anyone know what is an RFC? Okay, no, not too much. An RFC is like a Bayet blog that is really, really long. Here there are 43 pages with a technical English, and that's really time-consuming to read the whole RFC and know what to do with the RFC. So if you read an RFC, you'll need some Tylenol, I think. And the RFC is just something like if cases, some switch cases, more specifically. So if we are in this context, I will do that. If not, if I have this value, I will do that, etc. So I have an example with the expires either. So if it's not empty, I'm trying to parse it and set the lifetime to the expire duration minus the node timestamp. So we have this RFC that is the cache status RFC. So we take another Tylenol. So there is 100 pills in Tylenol. So maybe that's for that. The cache status lets you define a new header that is called cache status, and you say, okay, my cache called Sylvain has stored the response, and the forward is why it has been stored. So I missed the URI, so I didn't find any keys that match the requested resource. So I tried to load it through the upstream. In the second example, I say, okay, I got a hit. The key is available for 1, 2, 3, 4 seconds. And the key is get-domain.com etc. That is the stored key in your storage. And you can have many cache status because you can have swans that fail to get the cache response, but our Caddy instance that is placed behind our swan instance will hit the key. So it will be served from the Caddy instance instead of our upstream script. So you can place many caches layer in your stack with more or less TTL. So how to do that? We just say, okay, in my response, I will get the header. So that is basically an associative array, and I will set cache status and compute the header text in it. And I get from my context at the 7th line the cache name and compute the key from the context too. Okay, so there is also the targeted cache control, another Tylenol. The CDN cache control that is on all your CDN, so Akamai, Fastly, etc. And what we will do with this is to define a new cache control header that will say, okay, in my Swan cache control, I will store it for 1 hour. And in my low-level cache control, I will store it for 2 hours, etc. So you have a fine-grained configuration for each level of your storage, of your caching system. And you say, okay, in Cloudflare, for example, I won't store my response, but for my end user with just the cache control header, it will be stored for 600 seconds. Okay, so how to deploy a new version of a Go application? So you have some tests, some build step, and the release step. In the test, we just run the Golang CI lint, that is the official linter, and the most used linter in the Go community. We are running some unit tests with external services like Redis, depending on the storages. And we try to build the plugins, and we run some end-to-end plugin tests to be sure the environment testing is working. So with Golang CI lint, there is GitHub action here. We check out the code, install Go, and run Golang CI lint on our code base. For the unit test, we try to run the Go test in a race mode, so it will be run as concurrency, and if it detects a race condition, your test will fail. For example, a write and a read at the same time on the same variable. With services, so we mount a Docker Composer stack and run the test on it. For the build plugins, we have a template plugin in our GitHub workflows, and we define the name and the Go version that will be run in this plugin build test. For the end-to-end testing, we use Newman, that is a headless Postman engine. You pass your Postman collection, and it will run all the tests in it. And after that, we are trying to build for Docker and release on Docker Hub, release on Go Releaser. And here I'm releasing the new plugin that will be available in the assets of the release name for Træfik, and that's done. So for the future of this project, there are 3 points. So stream every responses to reduce the TTFB. That's the first byte to be returned and to be handled by the client. Have better performances and support the early int status code, because you can say to the user, okay, when you load this page, you'll have to download also the CSS or this JS. And if you have any idea, open an issue. So special thanks to these 4 men, Daniel West, Matt Holt, that built KD, Mohamed Al-Saaf, and Usam, that contributed to the project. So thank you for your attention. I hope you enjoy it. And
thank you, Sylvain. If anybody has any questions, feel free to raise your hand. And yeah.
What's the purpose of? Okay, so the purpose of multiple level of cache is to reduce, for example, the TTL. So your front cache will store it for like 4 days, for example, and when you get closer than your upstream, you can reduce the TTL because if you go deeper in your pipeline, you can request your upstream more often because your load will be handled by the front caches. Yep.
Does that complicate things with stale caches? Like so when you have multiple levels of cache with like different TTLs, then isn't the chance of having outdated content higher? Like
Yes.
how do you deal with that, if at all?
If you want to deal with that, you have to invalidate the cache to upper stacks, so upper caching levels. That's what Swan is doing with invalidating also the Cloudflare caches or stuff like that. So you don't have to think about that if you use a tool like that. But if you do it by yourself, you have to know your upper caching levels.
Any more questions? Thank you so much.